7, which is describing number patterns. Very first thing today is take a second to pause the video and write down these definitions. The definitions down. Inductive reasoning. Inductive reasoning is making a conclusion based on patterns that you observed. So you're kind of just using your brain, in other words, to figure out the pattern that's going on. Conjecture is a conclusion you reach from your inductive reasoning. So it's kind of like, oh, this is what I decided because I have looked this pattern over and have found it. So the first thing, you guys have done this before, it's not the first time. So the first thing I would like you to do is just take a look at this. Can you find the next two numbers? Or first of all, find the pattern and then find the next two numbers. So I have 1, 5, 9. Yes, adding 4. Okay, is my pattern. So as you can see here, they added 4 to each term like we just said. So our pattern, we found our pattern, is add 4 to the previous term. So the next two terms would be 9 plus 4, 13. And then 13 plus 4 is 17. So to continue this, we would have 13, 17 would answer the question for my next two terms. Next one here is 1, 3, 9. Please take a second to pause the video. Find the pattern and then find the next two terms. Alright, you should have found that you're multiplying the previous term by 3. 1 times 3 is 3. 3 times 3 is 9. So to find that next term, I'm going to do 9 times 3. I'm going to get 27. So I should have 27 next. Now take 27 times 3. 81. So the next two terms in this sequence is 27 and 81. Here's a third example. Pause the video, find the pattern. The pattern here is you square the consecutive odd integers. So my first one was 1. So 1 squared was 1. And then my next number after 1 was 3. For my odd integers that we're talking about would be 3. 3 squared is 9. My next one is 5. 5 squared is 25. 7 is my next odd integer. 7 squared is 49. What is my next odd integer? 9. So 9 squared is 81. My next would be 11. 11 squared is 121. So my next two terms should be 81 and 121. Take a second to pause the video to write down all 4 vocabulary words. Okay, sequence is another name for a number pattern. Term is each number in a sequence. So we just talked about the number pattern. We had 1, 9, 25, 49, 81, 121. So this is a sequence. All of these, it's another name for number pattern. And then this is a term. Number 9 is a term. 25 is a term. 49 is a term. 81, 121. So each number in here is a term. Arithmetic sequence is a specific type of a sequence. So when you add a fixed number to each previous term, is what we've been doing and will continue to do. Common difference, the fixed number and arithmetic sequence. So here we were squaring the odd integer. That would have been our common difference. We'll take a look at a few more common differences here. So 5, 2, -1, -4. What is happening here? Well, you're taking -3 from each one. -3 from the previous term. -3 from the previous term to get to your next one. So the common difference here is -3. Here's another example, B. Please pause the video, find the common difference. You should have gotten 3 as your common difference. You are adding 3 to each term. And it's 3, specifically it's 3 to each previous. So the term straight before it. So 8 plus 3 gave you 11. 11 plus 3 gave you 14. 14 plus 3 gave you 17. So the common difference here is 3. Okay, so now that you found the common difference, we're going to use that to eventually get ourselves into a rule for an arithmetic sequence. So what we need to do, you can use the common difference of the terms in an arithmetic sequence to write a function rule for the sequence. So what will that look like? Let's say here I had 7, 11, 15, and 19. Each one of these terms is like an output value. Okay, this is term number 1, term number 2, term number 3, term number 4. These numbers, which term number it is going to be considered my input. So output was the numbers given in your sequence. The term number, where it falls at, is going to be my input. Next, we need to find the common difference of this arithmetic sequence here to write the function rule. So what is my common difference? What's the pattern that's happening here? You should see it's plus 4 every single time. Okay, so plus 4 equals my common difference. Now, we're going to let n here equal the term number, so this one here, in your sequence, and a of n is going to equal the value of the nth term in the sequence. So what are you saying here? We're going to create a function rule. What does that mean? It means I can find any given value in a sequence. And when I mean value, I'm talking about any term. I can find any term in a sequence once I create a function rule. Well, how do you create the function rule? The function rule is going to be a of n equals a plus n minus 1 times d. So a of n, what is that going to stand for? This n is going to be your nth term. So whatever term you are looking for. If you're looking for the first term, you're going to put 1 in. If you're looking for the 5th term, you're going to put 5 in. If you're going to look for the 98th term in the sequence, you would put 98 in here for n. Okay? So a is my next variable here, and this is going to represent your first term in your sequence. Once again, n is the same as this one. It's going to be the term number. Term number. -1 will stay, and times is d. D is going to be your common difference. Okay? So what does this look like? This is given. Find the first, 15th, and 10th term of the sequence. So here we're lucky, and this is a little different than what I just explained because we know 5 here is my d value, and d was representing your common difference. So in my sequence, I know what's happening is that it's going up by 5. So that is my common difference. So let's start filling out what we know. I want to find the first term. So n is going to be the term number you're trying to find, which is 1. 15, which is my first number in my sequence. Okay? Now, the sequence isn't written out here for you, but this is the problem that's given. This is what they're going to look like in your practice work. If you had a sequence of numbers, 15 would be here first, and then I'd have another term, and another term, and another term. So you might be asking, well, why are we finding the first term then? It's obviously 15 because it's punched into your equation. You're totally right, but we'll continue to watch anyways. So 15 is my first term, plus, once again, this is n, and this is the term number. We're trying to find the first term. -1 always stays, and then times your d. And we already said that d has to be my common difference, and that's given for you. You do not need to find that. 15 plus 1 minus 1 is 0 times 5 equals 15. So, oops, go ahead and try to find the 5th term. So now you're looking for the 5th term. Pause the video to find it. This is what you should have gotten for the 5th term. So once again, it's a times n. N is the term number. We're looking for the 5th. Equals my first number in my sequence plus n, which is the term I'm trying to find, 5, minus 1 times 5, because 5 here is d, which is my common difference, which is just given in this example. It won't always be given because you can get a list of numbers, but for this time it was given. So you should have got your 5th term should be 35. Go ahead and find the 10th term. Pause the video. You should have gotten 60 for your 10th term number. Go ahead and start working on your practice problems.